Hello and welcome to this video. In this video, we shall see the next topic of advanced metrology, that is optical measurement and interferometry. So first of all, let us see the introduction. So optical measurement provides a simple, easy, accurate and reliable means for carrying out inspection and measurements. So these provides the optical measurements provides the simple, so they are simple to use, easy, accurate, so which is very important in case of the any inspections, and reliable means for carrying out the inspection and measurements. So sometimes, so instead of optical optics, you can also use the lasers. So lasers also being used, increasingly used in the interferometers for inspection, for precision measurements. So what is meaning of precision? So we have seen in the introduction of the metrology. So first, what is meaning of optical interference? So optical interference means, so when two light waves interact with each other. So when two light waves interact with each other means when two lights combine with each other. So the wave effect leads to the phenomenon means it will come, two light waves combine होने के बाद, so that will leads to some phenomenon, so that is called the interference of the light. So the instruments designed to measure with interference are known as interferometers. So let us see the what is interference, optical interference. So you can see here, so this is the figures, so where, so this is the light source A and this is light source B, means इधर एक light source रखा है, so इधर एक light source रखा है, so that is monochromatic light sources. So when you keep light sources, so whatever the light rays coming from this light source, light rays coming from light source A, light rays coming from light source B, so both will, so come from this, whatever the rays come from A and B, so that will combine and form a, what you can say, patterns or fringes on the screen. So दोनों का light rays combine होने से, so they will form the bands or fringes or patterns. So alternatively क्या होता है वो, bright and, so they will form the bright and dark bands. So here you can see again, so अगर इधर light source है, so this is the some barrier, means it is like some non-transparent wall. So उसके बाद here two holes are made, means light rays pass through here also. So इसके बाद क्या होता है, इधर combine हो जाता है light source whatever coming from here and here. So combine होने के बाद, so they will form the pattern, that is alternatively dark and bright patterns. So here you can see one more figure of same concept. So here you can see interference means इसमें देखो कि two light rays are combined here. So this is called the constructive interference means, so they are in same phase, you can see. So this type of interference leads to the bright bands, so उसका brightness क्या होता है, बढ़ जाता है, so that's why they will result in the bright bands. So here you can see, so this is called the destructive interference. So whatever the light rays, so they will combine by out of phase. So you can say these are called, they are in phase and these are in out of phase. When light rays make the interference by out of phase, so this will leads to the dark bands, means its brightness is going to reduces. So here it is a light source, so again same, it is some wall is used, so with two holes. So this light source, light will come from this hole also, this hole also. So whatever the light rays coming from here and here, so they will combine and form the different alternative bands or fringes, bright and dark. So this is called the interference. Interference means it is a combination of two light rays. So the phenomenon of interference is made use for carrying out precise measurements of very small linear dimensions. So this interference technique is used for so measurements of very small linear dimensions and measurement of, and the measurement technique is popularly known as interferometry. So इसको technique को क्या बोलते हैं? So this technique is called the interferometry. So this technique is used in variety of metrological applications such as inspection of machine parts. So we can use for the inspection of machine parts for straightness, parallelism, flatness, measurement of very small diameters, and so on. So specifically these are used for state to check the straightness, parallelism and flatness. So in this it finds a lot of applications. The instrument used for making the measurements using interferometry technique is called an interferometer. So here you can see, so this is the optical flat and this is a surface, मतलब जो surface को inspection करने के. So optical flat means it is a circular glass. So you can see here. So this is the optical flat. So optical flat is like glass object, glass circular object like some with some thickness. So these will be made of some high quality glass. So it will be placed on the surface of which we need to check the flatness. So these glasses will be placed on the surfaces of which surface flatness will be checked. So and on that you can, so what you can say, supply the monochromatic light source. So जिस जो सरफेस को इंस्पेक्शन करने के उस सरफेस के ऊपर एक ऑप्टिकल फ्लैट को रखने का, सो दिस आर द ऑप्टिकल फ्लैट्स, उसके ऊपर रखने का, सो उसके ऊपर रखने के बाद सो उसके ऊपर मोनोक्रोमेटिक लाइट को सप्लाई करने का. After supplying the monochromatic light source, so you can see the different fringes. So different lines आपको दिखता है depending upon the surface, whether the surface is flat or not. So you can see here, so an optical flat is a disc of high quality glass or quartz, means it is made up of the high quality glass or quartz material. When an optical flat is laid over a flat reflecting surface, means so इसको ऑप्टिकल फ्लैट को एक सरफेस के ऊपर रखने के बाद, so which will be reflecting surface, it orients at a small angle theta because of the presence of air damper between two surfaces. दोनों के बीच में जिसका एयर होता है तो उसके वजह से so there will be some angle between the two surfaces, means जो inspection surface है और optical flat का surface है, दोनों के बीच में so it will maintain some angle. So next you can see, so how we can check the flatness. देखो, so when the surface is flat, so you can see this type of lines, that is straight lines. So जो सरफेस को इंस्पेक्शन करने के, तो उस सरफेस के ऊपर ऑप्टिकल फ्लैट रख के उसके ऊपर मोनोक्रोमेटिक लाइट सोर्स सप्लाई करके, सो इफ यू सी, you can see the this type of straight lines if the surface is flat. If the surface is not flat, so then you can see, so this type of lines means these are not straight lines, so these are the curved lines, these are the curved lines. So that's why, so the surface is not flat. So by this way, so we can check the flatness of the surfaces by using the optical flats. So this is also technique is interference technique it is. So next is interferometers. So in case of the optical flats, an interferometer works on same basic principle as that of optical flat. Optical flat जो टेक्निक यूज करता है, तो उसी टेक्निक पे ये भी वर्क करता है. So it is provided with some arrangements in order to control the lay and orientation of fringes. So it will have some additional instruments, additional parts. So it is also provided with some viewing or recording system, so which will eliminates the measurement errors. So it will make you some measurement easier as compared to the optical flats. So you can see, so this is the N.P.L flatness interferometer. So N.P.L means it is National Physical Laboratory. So this is the called the N.P.L flatness interferometer. So what is there here? So here you can see, so here it is light source. So that light will be strike on this collimating condensing lens. Condensing lens will converge the whatever the light rays. So afterwards here it is a green filter. Green filter means so it will allow only green light rays. Afterwards next comes here it is a pinhole. Pinhole means it is having small hole, so through which this light rays will going to pass. Afterwards whatever that this light rays is going to pass, so these light rays will be strike on the, so light rays from mercury vapor lamp is condensed and passed through the green filter. So light rays from light source will pass through the condensing lens and green filter, resulting in a green monochromatic light source. Means it will result in the green monochromatic light source. Monochromatic light source means, so whatever the light rays, they should have same wavelength. So afterwards, so the light will now pass through the pinhole. So this is the pinhole. So light will now pass through this pinhole, giving an intense point of monochromatic light. So this will give the intense point, what you can say, intense point source of monochromatic light source. So next is, so this whatever the pinhole, so this is positioned in such a way that the focal plane of collimating lens, so this is the collimating lens, so this pinhole will be placed in the focal plane of this collimating lens. So therefore the collimating lens projects a parallel beam of light onto the face of the gaze to be tested via optical flat. So this pinhole is placed in the focal plane of this collimating lens. So because of that, so whatever the light is falling on this collimating lens from the pinhole, so that light rays will direct will what you can say, make this collimating lens will make the whatever the light is coming from this pinhole, so it will be parallel. So whatever the light rays coming out of this collimating lens will be parallel, and that will be strike on the optical flat. So through this optical flat, so there is a, so this is the base. So this is the base. So and on this base, so there is a workpiece is kept, of which we want to check the flatness. So whatever the light rays through this optical flat, so that will be fall on the workpiece, and afterwards it will be reflected back. And there it is a eyepiece, so where you can keep the eye, and you can see the fringes. आप fringes को देख सकते हैं, formation of fringes. So here you can see, so you can see this type of fringes, that is actual view. This will be this will be the actual view you can see. So suppose if the fringes are straight, then the whatever the surface it is flat. So if the surface, if the fringes are not straight, then whatever the surface, workpiece surface is not flat. So in this way, so we can check the flatness of the surfaces by using the interferometer, that is N.P.L flatness interferometer. So thank you for watching this video. So if you have any doubts, so you can ask personally also. So I will stop here, so I will see in the next video.